Integration by parts is one of those special, delicate little tools in the calculus toolbox. It's kind of like a favorite pair of tweezers. When you have that favorite pair of tweezers in your hands, you can fix all sorts of very small, delicate mechanisms. But it doesn't work for everything. There are some things that are just too big or too unwieldy for those tweezers. But when it works, it is great. So integration by parts is not something you'll necessarily use all the time, but when it works very well. And really, the integration by parts is the integral analog of the product rule for derivatives. I've got it up on the screen here, and what it tells you is it tells you how to integrate integrate a function that's written out in a particular way, and you can kind of think of it as moving the derivative from one side to the other of some function. Now, this is a very abbreviated form that I've got up on the screen, one that is easy to remember from a technique standpoint, but perhaps not the most enlightening. So let's be a little bit more explicit. So you start out with a product. So I have a product of two functions, say f and g, and I'm going to take their derivative. If I take their derivative, well, what's that? That's the product rule. It's not the derivative of f times the derivative of g. It's f prime of x, g of x, plus f of x, g prime of x. Okay, and I said this is integration by parts is the integral analog of this. So if I integrate both sides, in fact, let me just copy it. If I integrate both sides, then I will get three separate integrals that are somehow related and somehow a little bit different. But that's the essence here. So what do? I say I'm going to integrate, let's say, from a to b. And I'm going to integrate from a to b. And I'm going to integrate from a to b. So all I've done is I've essentially integrated both sides of the product rule formula. Now when I do that, you'll notice right away that this left side here is the integral of a derivative. The fundamental theorem of calculus tells me exactly what this is. This is f of x times g of x. Evaluate between a and b. This other side is the same, unchanged. Okay, and in order to get the integration by parts formula, all you need to do is move one of these two terms over to the other side. Doesn't matter which one you do. So let's do this. This guy is going to equal, oops, I want to copy. And there's your integration by parts formula. This is the same formula that we had up above. It's just written a little differently. See, I have this f prime, or rather, okay, so the way that I have it written there, this guy here is u, and f prime of x dx, that's dv. This is the uv, and this guy here then becomes v, and this guy becomes du. But the thing to realize is essentially what I've done is I've moved the derivative from the f onto the g. The cost of doing that is some terms that involve the endpoints and an extra minus sign. Okay. But this is the form, and so I think it is definitely worth doing an example. So typical integration by parts formulas look a bit like this. We saw with the substitution video what happens when I have an x squared there. But what if I just have an x? Okay, so a substitution is not going to work here. There's no real substitution I can do. But what I can do is I can say, you know, I can say that I really would like to take a derivative of x, because I know what the derivative of x is. That's just 1. And on the other hand, I don't mind taking an integral of e to the x. That's no problem. So I usually write out my form, my integration by parts form, by writing out u and dv, choosing u to be the thing I'd like to take the derivative of, and v to be all the rest, which I'm forced to take the integral of. You can kind of think of it the other way around, too. Strategically, if there's something you cannot take the integral of, do not make that dv. Make it u. All right, so once I've done that, then I pick out the formula. The formula says u times v, and that's these guys here, u times v. And that's evaluate between my endpoints. I don't have an endpoints, this being an indefinite integral, so there's a constant. And then minus the second two guys. Minus the second two guys, the integral of the second two guys, well, that's a 1 times e to the x. Oops. Let me do it not in red. And you'll notice I've got my dx to integrate this neatly. And of course, I have no problems integrating e to the x. I've already done that once in this very problem. And there is your answer. Now, sometimes you'll have to do integration by parts multiple times. That's fine. Be prepared. Be strong. Just keep going. And sometimes for trig functions, you'll have to do it. You'll realize that you've gotten back to where you've started. You've looped around. That's okay, too. All of these sorts of things can be managed by algebra, and it's not really a big deal.